Hello, ladies and gentlemen. We're going to do the second part of 4.9 today. We're going to be solving more quadratic inequalities. All right, so that is our task for today. All right, here's our objective. We're going to continue working with our quadratic inequalities. Oops. Okay, so we're going to continue working with our quadratic inequalities. So today, we're going to solve algebraically. We're going to put our answers in interval notation. And then we're going to solve graphically. And our graphically is going to have a new twist, which is kind of cool. Sorry. Okay. So I'm just going to start by doing some examples and then kind of work through the process. All right, so here's our first example. You're going to be given x squared minus 5x is less than 0. And I'm going to ask you to solve this algebraically. All right, so here will be your process. First, I'm going to factor to find what's called my critical points. And the critical points are actually going to be the x-intercepts, but we're going to put these when we start on a number line instead of on a graph as a parabola, and then we'll change. All right, so if I solve for my critical points, I would do x times x minus 5 is equal to 0, and I would get x is equal to 0 and x is equal to 5. And then I'm going to put those values on a number line. My number line's a little bit crooked. And I'm going to put my 0 and my 5. That creates some intervals on my graph. Okay? So then I need to test values in each of the intervals. So I'm going to test, and I'm just going to write those down so you know which values I'm testing. I'm going to test a -2. I'm going to test a +2. And then I'm going to test, say, a 7. So I'm going to put those values back into the original equation. So if I test my -2, I would have a -2 squared minus 5 times a -2, and I want to know, is that less than 0? All right? So if I do that math, I'm going to get 4 plus 10, still looking to find if it's less than 0. 14 is not less than 0, so that means that the very left interval doesn't apply to this particular graph. My original inequality said less than, so I'm going to put an open circle on my 0 and an open circle on my 5. All right, so now I'm going to test the +2. Okay. Alrighty, so if I test the 2, I would put it into my original equation, so I would have a 2 squared minus 5 times 2, and then I'm wondering, is it less than 0? So this is 4 minus 10. Is this less than 0? Well, a -6 is in fact less than 0, so that means that this interval on my number line works. So I'm going to shade in my interval. Now I'm going to test the 5 just to verify. So if I substitute that back into the equation, I'm going to have 5 squared minus 5 times 5, and then is that less than 0? And actually, I said I was going to do a 7, so I'm going to change that to a 7 and a 7. All right, a 7 squared is going to be 49. Guess I should change this as well. that's a 49, minus 35, and I'm wondering if that's less than 0. So I have a 14 is less than 0. No, that doesn't work. So my solution is in between 0 and 5. So if I wrote it as an inequality, it would say that x has to be greater than 0 and less than 5. My preference is interval notation. And if I put it in interval notation, open bracket because the 0 is not included. The 5 is also in an open bracket because it is not included. All right. Now I'm going to do the same problem a slightly different way. All right, so if I do my next problem, so it's the same thing. I had x squared minus 5x is less than 0. I'm going to find my critical, that's a C, values. And we've already found them, but I'll just go ahead and rewrite it so we can see it again. And I get that x is 0 and 5. So now what I'm going to do is I'm going to actually graph the parabola, and I'm going to graph it by hand. I don't need the vertex in this particular application. I just need to know if the parabola goes up or down and what its x-intercepts are. So I have an x-intercept at 0, and I have 1 at a positive 5. My x squared value is positive, so I know that the graph goes up. So this is our slight different twist. Less than 0 means that it is below the x-axis. Okay? So less than 0 means that it is below the x-axis. So I'm going to get out my handy dandy highlighter, and I'm just going to highlight, this is the portion of the graph that's less than 0. So then I would put my answer in interval notation. And I want to talk about the interval where x is less than 0. It happens between 0 and 5. So it's actually kind of cool to be able to graph these without solving algebraically. All right. So now let's do another example, and again I'm going to do it both ways. All right. So I'll give us a new problem. Scoop my paper up. So here's our next example. So I'm going to do it two ways. I'm going to draw a little dividing line. So this way is going to be algebraically, and this side is going to be graphically. And that will be with our new little twist on our problem. So the first part of it, here's my equation. I have x squared minus 2x is greater than 15. As with all quadratics, I need to have a 0 on the right-hand side to be able to solve. So I'm going to rewrite this to be x squared minus 2x minus 15 is greater than 0. I can factor this to find my x-intercepts. So it's going to be x minus 5 and x plus 3 greater than 0. So I know that my x-intercepts are going to be at 5 and a negative 3. Okay, so I'm going to put those on a number line. And again, this is because they're asking us to solve graphically. Okay, again, it said greater than, so my critical points are not going to be included as part of the solution, and I need to test values in each of the intervals. So first I'll test a negative 4, totally random. I just picked a number in this particular interval, and I'm going to substitute it into my equation here because I think that's going to be a little bit easier to manage the math. If I do that, I get a negative 4 minus 5 times a negative 4 plus 3, and I'm wondering if it's greater than 0. So I get a negative 9 times a negative 1 greater than 0. A positive 9 is indeed greater than 0, so that interval actually worked. Okay, scoop my paper up. So then I'm going to shade that particular interval because it was true. Now I'm going to test a value in this interval. I'm going to test a 0 because 0 is nice. So I would get a 0 minus 5, and then a 0 plus 3, and I want to know if it's greater than 0. A negative 5 times 3 is a negative 15, and a negative 15 is not greater than 0. So the middle interval is not part of my solution. The last value that I'm going to test is a 6, totally random again. If I substitute that in, I'm going to get 6 minus 5 times 6 plus 3, and I want to know, is it greater than 0? Well, 6 minus 5 is 1, 6 plus 3 is 9, and 9 is definitely greater than 0, so then I'm going to shade this piece. And I'm going to write my interval up here just up above my graph since I kind of ran out of room on my paper. So the solution for this one, remember I read from left to right, is going to be a negative infinity to a negative 3. The negative 3 isn't included, unioned with, and then I'm going to start again at 5, not included, and go to positive infinity. And so this would actually be my solution. Okay. So now let's do this same problem graphically, talking about above and below the x-axis. Okay? So my equation was x squared minus 2x minus 15 is greater than 0, which means that I'm looking for above the x-axis. Okay? All right, so we already found our critical points. We had x is equal to 5 and a negative 3. Guess I don't need that. Okay, so I'm going to go ahead and put that information on my graph. So if I have a negative 3, 2, 3, there's a negative 3, and that was one of my intercepts. And then I had a positive 5, 1, 2, 3, 4, 5, and that was an intercept. My A is positive, so I know that my graph goes up. Okay, so there's my basic graph. And I want to know, where is the graph above the x-axis? So it's from this piece and this piece. So those are the two portions of my graph that are up above the x-axis. So then my solution, remember I always read left to right. So I'm going to start at a negative infinity, and I'm going to stop at a negative 3, not included, unioned with, I start at 5 again, and I go to positive infinity. And those are the two portions of my graph that are up above the x-axis. So that's kind of a cool way to think about a solution to a problem. All right, so now let's do another example, and I'm going to do the same thing with this one. We're going to solve it algebraically, and then we'll solve it graphically. All right, your equation is going to be 2x squared plus x minus 4 is greater than or equal to 0. So if I look at this right off the bat, I notice that it's not factorable. So I'm going to do the quadratic formula to come up with my critical points. All right, so I know that x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. All right? And then at this point, I'm just going to simplify it a little bit, and then I'll finish the rest of it in my calculator. So I'm going to have 1. 4 times 4 is 16 times 2 is plus 32 over 4. So that's going to equal a negative 1 plus or minus radical 33 over 4. I'm going to bring in my handy dandy calculator, and I'm going to clear our cool graphs from the day before. And then I'm going to enter that math. So in parentheses, there's the negative 1 plus the square root of 33, close for the numerator, divided by 4. And I got 1.186. Then I'm going to do a second enter, bring that operation right back up, edit that to be a negative, and then I got a negative 1.6 1.686. All right, those are my two solutions to my quadratic formula. So those are my critical points. So if I were doing this algebraically, I would put those numbers on my graph. This would be the negative 1.686. This is the 1.186. It says greater than or equal to in this particular problem, so that means there's a closed circle on each of my two critical points, and I'm going to test values. So I'm going to let x equal a negative 2, and I'm going to substitute it back into the original equation. So there's a 2 times a negative 2 squared plus a negative 2 and then minus 4, and I want to know, is that greater than or equal to 0? So this is 2 times 4 minus 2 minus 4, 8 minus 6, so I get 2, and that is actually greater than or equal to a 0. That means that I'm going to shade the portion that was true. Now I'm going to test a number in the middle, and I'm going to test a 0 because zeros make my life easy. So I'm going to have 2 times a 0 squared plus 0 minus 4, and I'm wondering if it's greater than or equal to 0. So I get a negative 4 is greater than or equal to 0. That is not true, so I'm not going to shade this particular portion of my graph. All right. The next value that I'm going to test, just to make sure, is a 2, because that's in this interval out here. If I run it through my original equation, I'm going to have 2 times 2 squared plus 2 minus 4, and I wonder if it's greater than or equal to 0. So 2 times 4 plus 2 minus 4, so I'm going to get 8 minus 2, and then since I'm running out of space, I'm going to get 6 is greater than or equal to 0. That's true, so then I'm going to shade that portion of my graph. And then I'm going to write my solution. So my solution, I'll just kind of write it right here. My solution is going to be from a negative infinity to a negative 1.686. This time that value is included because the inequality said greater than or equal to. And then it starts again at a 1.186 and it goes to positive infinity. And then this is my solution algebraically to our equation. All right, so now I'm going to look at this graphically. I've already found my critical point, so I don't need to do that again. So I know that x was equal to 1.186 and a negative 1.686. I'm going to sketch my graph, just a nice simple sketch because it helps to visualize. Here would be my negative 1.686. This is the positive 1.186. Okay, my A is positive, so I know that the graph goes up. So my graph is going to look something like that. The inequality said greater than or equal to 0, so it's this piece because that's above, that's at the x-axis or above, and it's that piece which is at the x-axis or above. Since it said it could be equal to 0, that means I actually include the intercept. So then if I wrote my solution in interval form from here, it would be a negative infinity to a negative 1.686 included. Infinity can't have a boundary, unioned with, and then I'll write it down here, 1.186 to positive infinity. And I got the same solution two different ways. So that's kind of nice. Kind of a fun way to talk about those problems. All right, your lecture's over. Now we're going to get to your problems. You only have 2 because each problem takes a little bit of time. I want you to solve each inequality, both algebraically and graphically. Remembering that if it says it's greater than 0, it's above the x-axis. If it says greater than or equal to 0, that means it's at the x-axis and above. Less than 0 is going to be below the x-axis. Okay. And then less than or equal to 0 is going to include the x-axis. All right, so your first problem, number 1, is 2x squared plus 2x is less than or equal to 3. Remember, I can't solve a quadratic unless I have a 0 on the right-hand side. And then your second one is 2x squared minus 7x is greater than 4. So solve each of those two inequalities both algebraically and graphically. Good luck and have fun with your highlighting.